Okay, well, good morning, everyone. My name is Keith Hewlin. I am the Director of Business Development for Ascent Geomatic Solutions. We're glad to have everybody join the webinar. Today we're going to be talking about a really interesting concept that we've been developing for the last couple of years, and we're excited to share with all of you. We are recording this, so if you, for whatever reason, you have to leave the webinar, you can always go to our website here in about a week or so, and you should be able to see it there. Well, why don't we go ahead and get started as we're at 10 o'clock here Mountain Time. Today we're going to talk about the benefits of UAVs and LiDAR for upstream operations. Before we do that, I want to just go through a quick agenda. So our agenda today, we're going to talk just a very quick overview about Ascent so everybody understands who we are, and then just a quick bio on the presenters we have today. Then we're going to go through UAVs and LiDAR 101, so essentially just going through some basic terminology, then discussing why UAVs and LiDARs in general, and then digging more into specifics about UAVs for new locations and planning purposes, as well as LiDAR for as-built, flow lines, and facilities. And then we'll finish off by recapping, doing a summary and some recommendations, and then last but not least, some questions from all of you. So real quickly, we'll just give you a quick background on Ascent in case you're not familiar with the organization. For the past 11 years, Ascent has specialized in collecting, analyzing, and delivering geospatially accurate data so our customers can make more accurate and timely business decisions. Now, many of the people on this call might be familiar with our former name, which is Petroleum Field Services, or PFS. But in January of 2017, PFS decided to rebrand to Ascent Geomatics. And this is due in part to some of the new technology we've been using and also some of the new industries that we have kind of moved into. But over the past 11 years, we've grown from a one-person operation into a company that employs about 80 people, with our headquarters being in Denver, Colorado, and field offices in Williston, North Dakota, and Midland, Texas. Our main industry focus obviously has been and still is and always has been oil and gas, but we also serve additional industries like transportation, civil infrastructure, land development, and mining. Our core service offerings, which we'll talk about here in just a second, are surveying. That always has been our core service offering, but over time Ascent has expanded our core offerings to include civil engineering, GIS services, regulatory and permitting services, water sampling, and then what we're going to focus on today, which is the remote sensing, talking about UAVs and LiDAR. So with that, I'm going to go ahead and discuss who the presenters are today. Again, my name is Keith Hewlin. I'm the Director of Business Development. I'll be kind of facilitating our presentation today. And I'm joined here with Owen and Nick. So you guys want to say hi real quick?
Hey, everybody. Hey.
So Owen here has over 10 years of survey experience and has been with Ascent for just over 7 years. He currently manages all our remote sensing projects, which includes field work, using terrestrial LiDAR and UAV services, drafting exhibits, and a whole bunch of other things. And he also trains our entire team. We've got about 6 pilots in command, or PICs, people that fly drones, and he manages all of those folks. Prior to joining Ascent, Owen worked for the city of Aurora, which provided him experience as a municipal surveyor, adhering to CDOT and national standards. He's done boundary, construction, control surveys, and he's also gained experience through drafting, updating GIS databases and control networks, and worked very closely with public and private entities to plan and complete publicly funded projects. He holds a FAA Part 107 remote pilot's license and a certificate in GIS. And he also holds a BA in both physical geography and archaeology from the University of Denver. Nice. Thank you. And then we were also joined here by Nick Cosina. Nick has over 7 years of experience in the energy sector, specializing in upstream and midstream oil and gas project management, and has been with Ascent for, how long have you been with Ascent for?
4 years.
Oh, a little over 4 years. Nice. He currently manages Ascent's upstream program, which includes developing strategic and tactical plans, as well as day-to-day project management with certain clients. His experience has provided him experience in well site geology, geosteering, drill rig oversight, water sampling analysis, and a whole bunch of other stuff in the oil and gas sector. Nick has specific experience working on permitting projects in North Dakota, Wyoming, Colorado, Texas, and has worked on some innovative solutions for surveying and permitting locations from initial concept all the way through as-built. Prior to joining the team, he worked as an assistant manager at geosteering operations for Selman and Associates and a geologist, hydrologist for Whetstone Associates. He holds a Bachelor of Science in Geology from Radford University. So these are your presenters today. And now let's go ahead and dive into the presentation. To frame this a little bit, I think it's good for us to give a quick background on UAV and LiDAR terminology. So we're just going to do a quick 101 here. When we say UAVs, for those of you not familiar, we're talking about unmanned aerial vehicles, or commonly referred to as drones. When we talk about LiDAR, we're talking about light detection and ranging. So this is essentially similar to sonar or radar. It's essentially sending out pulses and then getting a return on those. But in the case of this LiDAR, we're talking about light pulses, and we're talking about millions and millions and millions of these that are going out. This can be done terrestrially on the ground, mobilely on a ATV or on a backpack or on a truck, and it can also be done aerially through the use of a UAV or a drone. From a drone perspective or a UAV perspective, there are different types. You've got a multi-rotor, which you see up at the top in the yellow, and that's where you have multiple rotors. Those are generally going to be flying a little bit lower and slower and can sometimes pick up a little higher resolution. The fixed wing, which you see on the right over there, the black, what we'll commonly refer to as more of a conventional aircraft frame, that's going to fly a little bit higher and a little bit faster. It's better for long corridor type of projects. And then the last thing we'll mention is point cloud. So this is a set of data points in a 3D coordinate system defined by X, Y, and Z coordinates. So basically, it's taking all of that data and combining it into one very dense collection of data points, and then being able to see that and render that into a 3D type of a model. So next, we can talk a little bit about FAA and local regulations, but to do this, since Owen, we have our pilot in command here, I'm going to have him go ahead and talk to some of these.
Yeah, thanks, Steve. Essentially, to be able to fly a UAV legally, there's a number of restrictions that you do have to follow, along with certain licensure. Right now, we function under both 333 exemptions and Part 107. Last year, in the summer of 2016, they switched the rules down to try and make it a little more accessible for more people to be able to go out and actually fly drones commercially, which was the Part 107. We now are able to get out and have more efficient one-man crews under that rule versus the 333, where you had to have a two-man crew with a FAA single-engine full-on pilot. So it made it a little more difficult to navigate those rules. While with the 107, we're a lot more functional as long as we follow FAA rules and regulations. We have to be within sight of the unit while it's in the air at all times. If we're within 5 miles of an airport, there's certain restrictions that you have to do, and there's certain authorizations that you're going to have to try and acquire. You have to have legal takeoff and landing areas. You can technically fly over just about anything, but you have to be able to take off and land legally, so you need surface permissions to do so. There's also certain local ordinances that can be followed or need to be followed depending on county, city, and a variety of other restrictions. But in the end, just like a lot of things, there's always waivers and permission exceptions to a lot of these rules that allow us to be able to fly in a vast majority of areas.
Great. Okay, so before we go into this next section, I just wanted to remind everybody that's on the call that on your dialog box up in the right-hand corner, you may have a little arrow, an orange arrow. If you click on that, you can ask questions. So we would go ahead and ask that if you have any questions throughout the rest of this presentation, please go ahead and submit them there. And then we're going to save about 10 minutes at the end to make sure that we answer any questions that are out there. So now is the question, why UAVs and LiDAR? So let's talk about this just kind of at a high level here. And I'll let Owen, since he's our local surveyor, kind of talk through the evolution here of surveying.
Yeah, so kind of on the slide there, you see, all the way back hundreds of years, surveying's been going on in conventional methods, from pulling chains and using a transit like the guy on the left is using there, which was very arduous, took entire teams of people to accomplish a land survey, a boundary survey, all the way up to, the onset of GPS back in the 70s into the 80s, when it became really common practice that surveyors can utilize GPS and the satellite navigation to create points and create the surveys. This constant evolution, it's always made life easier, but it's also increased the demands. And so with the increased demand on more data, faster, quicker, Ascent in the last couple of years, we started researching into and using LiDAR and UAVs kind of on the right side of the screen there. Ultimately, with anything, technology makes things better, makes it quicker, makes it faster, but you get more. And ultimately, compared to what the guy on the left would do from chaining and using a transit and physically writing notes down, we're able to now go and collect thousands of acres within a day with a UAV. So we have a pretty significant evolution over the last 100 years in conventional survey methods that allow clients and everyone to have more intelligence of the ground surface that they're trying to look at, evaluate, and plan on.
Right, so we're just talking about a new tool set for a new day and age here. And again, in the next few years, you're going to see, as GPS is more common now, you're going to see these tools on the right, UAVs and LiDAR, being pretty much common practice here, probably in the next, certainly in the next few years. And by the next 5 years, that'll pretty much be the standard.
So why use UAVs and LiDAR compared to the conventional methods? One of the main key components, as long as you're following all regulations and you're doing everything legally, it's increased safety. You're able to keep people off the ground and out of harm's way a lot better than conventional methods. You have less field time because you get more in less amount of time. Because you're getting more, you have fewer return trips to the field. And ultimately, you're collecting more of that data the first time, so you eliminate how many times you have to go back. And with that, you're able to enhance your project planning. You have more intelligence of the ground, what's around, what potential hindrances could impact your design and layouts. And ultimately, that creates better project efficiencies because you can have better collaborative data management, which we'll show you a little later in the webinar, some of the byproducts and the items that come out of these technologies. And then ultimately, you also get a lot of really great visuals that you just wouldn't get out of a conventional survey.
Yep, and that engaging marketing could be used for reclamation purposes or a number of other types of reasons. So Owen, you want to just kind of, as we dive into these, just take UAV and let's take LiDAR and just kind of divide these up and very quickly kind of talk about, from a oil and gas perspective, a couple of benefits for each one of these?
Yeah, definitely. So starting with location reconnaissance, every site starts as a greenfield. It starts as a location that's relatively untouched, or it could be an existing site that you want to add on to. You go out, and understanding what's on the ground is absolutely important. So UAVs make it quick, efficient, and very low impact. We don't have to have a surveyor going up and collecting a shot on someone's fence near their backyard. We're able to keep it in the air. And what that allows us to do, it allows us to have an enhanced routing perspective. So if there's going to be issues, if we're routing a pipeline corridor, let's say, if there's water features, we're able to capture that ahead of time and eliminate any issues of routing along the way. It also keeps, again, if you have water or if you have steep embankments, you can keep people out of harm's way by collecting it from the air. You can also use it for generalized planning for EH&S if you want to do sort of site progress and monitoring. You're also able to ultimately get a variety of byproducts out of it that you can use for site planning, for EH&S, and then ultimately the whole idea is that you get all this faster and it's safer.
Okay, very good. So what about LiDAR then?
So LiDAR is really nice, especially the terrestrial bays that you see a couple of the examples for on the right, as built to facilities and ultimately completions on facilities. If you can get down to literal millimeter accuracy on the facility, if it comes down to retrofitting and expanding and adding on, you know exactly where everything is, and you can fabricate out new piping, new structures. You can basically get that data at the end of a project and keep that for the entire life cycle. And ultimately what that means is that you can create 3D models, you get more, you house more, and you don't have to go back after the fact to expand, retrofit, and understand what your facility is comprised of.
Yeah, and it says safer with more data down there. I mean, you know, I see that example down in the bottom right where it looks like, you know, you're kind of inside of a facility. Do you need to get inside these facilities?
You don't have to. That's the nice thing, is that you can do all of this from the exterior, you know, and it really comes down to the operator, the client, safety rules and regulations. We always like to make sure that we take everything into account. If you have intrinsically safe areas, we're going to take note of that. and we're going to be off-site. If we are at a facility like the one you're seeing there, an example, may not be in production quite yet, so we're able to go in some areas, some containment areas that maybe wouldn't be safe once it is live.
Okay.
So just, you know, every location is always different.
Okay, great. All right, so let's talk now. We're gonna, you know, divide this next latter half of the presentation up into kind of two major areas. One is going to be in UAVs for new locations, pads, and planning purposes, and then the second half is going to be more focused on the as-built and flow lines and some of those types of concepts. So to dive into this now, I'm going to have Nick, if it's all right, I'm going to have you kind of talk through what does an operator, and in your experience working with some of our clients, what is the process that they go about today? How do they put a new pad in and decide they're going to start drilling in that location?
For sure. So permitting is always the first hurdle to get through. In order to do that, you have to be able to actually go out, speak to these landowners, make sure to keep them happy, all at the same time while making a legal, defensible location plausible for drilling your oil and gas wells. So as you know, the industry keeps on churning, you know, regulations continue to go up, and landowners continue to get even more angry when they see, you know, they see and hear things come out about how bad fracking is and all that kind of stuff. So the big thing here is how do you leave the least footprint and get the best location possible? The challenges here, just defining the least locations, and a lot of rework that goes in when landowners and or the state, municipality, or the county come in and really go after you. So business outcomes, extended permit times, and higher costs ultimately.
Yeah, so you know, business outcomes can either be positive or negative. Obviously, in this scenario, we're focused a little bit on the negative, but when you do have to send it, what you're saying then is basically if you have to send a survey crew back out to the same exact location 4 or 5 times until you've got your final location, then obviously that's going to extend the permit time, right?
Every time.
Right, and every time you've got to send a survey crew back out there, I'm guessing they don't go back out there for free the next 3 or 4 times?
Exactly. I mean, most survey companies are consultants, and especially in the oil and gas industry, you know, going back out, even if it's just to collect a new access point or something that simple, it's still a half a day, especially considering driving to remote locations and getting this kind of stuff done. So.
And what are the reasons, just real quickly before we jump off this slide, I mean, what are some of the reasons that the survey crews do end up going back out there?
A lot of times it's landowner preference, or you get an SUA, surface use agreement, on the front end with the landowner, and then you come to realize that that pad disturbance is too small. The landman may not have accounted for everything that was going to go into that, especially adding MLVTs, modular large volume tanks. You know, all these things come up later that weren't thought about on the front end, and it can definitely make a hassle. So.
Yeah, and what someone thinks is a flat field may actually have some grade to it, so the earthwork can completely impact where all that goes.
Exactly.
And so one last question before we jump off, because I think this piece is really important. It's kind of identifying the status quo today. When folks are going out to these locations and they have a survey crew go out, are they mainly just telling them go out into this one sectioned off kind of piece of land? They're not having them go out and gather data on 1,000 acres, as an example, right?
No, exactly. I mean, the typical workflow we see is a client will provide, hey, here's what we're thinking, 10 to 12 acres. This is where we want it. The landowners seem happy with that. You have full permissions to go and do that. And just go ahead. We want to get full topography for that area and pick up, you know, whatever else you need to make sure that we can get the permitting exhibits completed and get this location permitted through with whatever governing agency that may be.
Yeah. So smaller areas for sure. Okay. So now let's fast forward. Let's talk about a new way of doing these locations and permitting on new pads. How does that work?
Yeah. So like I was saying, a lot of times what will happen is we typically just get that quick pad to go out and go ahead and survey. We bring it back in-house, and that SUA was already done, and then all of a sudden issues start to appear. So with the new process that we've been experimenting with over the last year, and also with a large operator in Colorado. Basically, we've been going out and we've been taking a large area. So they send us, here's the legal location that we're kind of thinking, and in order to, try to make the most usable location to get, these huge sites in Weld County, Colorado to work, we go out and before they do their SUA, we fly the whole thing. What we do when we fly that, we collect all the topography, we collect all of the cultural features such as fences, ditches, existing structures, anything you can think of, roads, and then we bring all that back in and we create a full DWG and Surface XML. So we send that to the client. The client then goes through and says, okay, how's everything looking? They've got the topography of the land. They can actually place this thing, how it works, how it may fit. They can then start to think, we can actually brainstorm on what else could you possibly need here. We can see that there's this existing utility here. Well, the safety setback as governed by the state, you're not meeting that here, so let's shift here. So before the SUA is even talked about with the landowner, they can go ahead and actually set a full location and we can move forward from there. Once that location is reviewed and good to go, we can then move on and confidently know that without any additional changes or additional field visits, we can move forward and get a usable location.
And so ultimately here, what we're really talking about is fundamentally changing the tool set that we're using, because now we're using UAVs, we're using new tools, which really then fundamentally changes the process of which they go about eventually getting to the permit. And I noticed, you mentioned the SUA now is not what it's starting with. This comes after we've done the survey, right?
It comes after the location was vetted and something that you're going to be able to use. And the other thing is, during those negotiations, your SUA probably won't go right the first time. Landowners are difficult. I know for everyone else who's either in North Dakota or Texas, it may be a little bit easier, but if you guys have heard about how stringent Colorado is with their regulations and just with the landowners out there, it's tough to really get a location that works. So if you go out and talk to that landowner and they say, hey, can you just tweak this around a little bit? I don't like the way that's going to look, it's over by my horses and it's just not, I don't feel safe about it. I'd rather you move it down here. Instead of us having to go back out and collect more data on that, we have that data so we can make that quick tweak and we move on with life.
And so you'll just basically pull that up on a computer with your client and say, okay, we've got a lot of land to work with here that we've got topo on, we've got culture on, we've got the setbacks. Where do you want to move it?
Exactly.
I mean, it's that easy, right? Okay. Yeah, I mean, it sounds like this is a bit of a paradigm shift, but obviously there's some pretty big benefits here. And if you look at the business outcomes, reducing permit time, that's huge, obviously, for everybody on this call. And then overall lower costs, right? Again, the simplest way of saying that, if you don't have to keep sending people back out again and again and again, there's that direct cost, but then there's also the indirect cost of the time it takes, God forbid there's a drill rig or something sitting there being idle when it's supposed to be coming onto that pad. That could obviously be expensive too. And then just time, right? Time is money. So what are kind of just, if we look at a side-by-side comparison here for an example, let's say 1 square mile, what would you see the differences being between just a conventional and UAV kind of LiDAR type of surveys?
Yeah, so the big thing with the conventional survey is really the amount of data. There's only so much that a single surveyor can complete within a day. So when we start looking at kind of the metrics going into this, for a conventional survey, you're seeing probably 1 point per every 16 meters. Not very much. 100 points per square meter with the UAV and LiDAR survey equipment. Basically what that comes down to is your topography. What is going on that ground surface? To go out there and take a couple shots, maybe on a 50-foot grid, you're going to get an idea. You'll get an idea. But if you really want to know, we can actually go and once we fly that, we have so many data points that we can go and actually create that full surface out. And we'll be able to get very close, much closer and more accurate on our dirt work quantities and everything like that. the topo, when you start thinking about a 12-acre pad, we're not just going to collect topo conventionally on just those 12 acres. We're going to expand out a little bit because we know that once the dirt work comes in, placing spoil piles, excess stockpiles, everything like that, it's going to expand further than that. So you're looking at probably a week to do the same amount as what you could do on UAV or the LiDAR. Again, going back to it, more field time conventionally, you're going to be less safe. Owen, what are you seeing right now for flying? Let's say a quarter of a section.
Yeah, we can go out and fly our UAV. You know, if you're talking about a core section, you want to look at a rough approximate area. I mean, we can get it kind of said and done in the field within a half day. And if you want to topo that full core section, or even take it out further, you want to figure out what other options you have within the section. Like you were saying, I mean, it might be a week's worth of time on the ground to get that level of detail, and what we can collect in a half day, even over a square mile, an amazing amount of intelligence. And so it just creates an additional amount of data, but there's also a lot of byproducts that you get that we'll dive into also, that you're getting beyond just, you know, a traditional survey, like you're saying, of a point every 50 feet. You're getting an immense amount of data.
So the main difference that you're seeing here between the conventional and the UAV/LiDAR is the amount of data that you get in a quicker amount of time. It's usable data that will help you plan your full assets and make sure that you can get those permits on time and continue to use that data down the road for any kind of improvements.
So let me just ask a quick question here, in case somebody on the phone is thinking about, on the call is thinking about this. Do you still get your same deliverables if I'm using a UAV? I mean, I'm used to getting an exhibit package by the company I'm working with, the survey company. Do I still get that? You're talking about all these other things that we can do, these other cool things. I think we're going to see some examples here in just a minute. Do I still get my standard package?
Yeah, absolutely. Because what we do is we combine the survey together. We take the tools that are needed with the requirements that the governing bodies need, with what you need to produce, and we create your standard plat deliverables. We create your standard exhibits, and then ultimately it's going to always be in a usable, small contained format. We'll show you some examples here where you see an immense amount of data, and it's fantastic to look at, but it might be difficult for you to work with. So we'll ultimately produce a surface model of the ground. We'll draw in all given features that exist, and we'll deliver, if it's a CAD file that you need, a basic small CAD file that you can literally email over. It's not going to be gigabytes and gigabytes of data, but the advantage is that we have all that in the back end. So if you need to produce additional exhibits, additional content, we can keep producing those traditional paper exhibits for you, or PDF exhibits that you need, just as you'd always expect. You just get a whole lot more for roughly about the same.
Okay, good. And so just two quick examples here, just for visual sake. Conventional on the left side, UAV on the right side here, and we're going to go through some of these more specific types of examples now. So you know, let's start kind of on this example. What are we looking at here?
So on this one, we're basically looking at the planning. Okay. So construction layouts, you know, this is on the left, you'll see a typical grading plan. You know, how is that pad going to be graded out, and what kind of dirt work are you going to need to do on that? Basically, from the data that we bring in, we get very accurate topo. Sorry, on the right, you can see kind of the topo overlay and all of the data that we actually pick up using the UAV. So from all that data, you can actually go and look at your setbacks, 500 foot, 1,000, up to, you know, whatever the governing agency is. We can collect all that data on the front end and actually provide that. All of these things go into making that location perfect. A lot of times what we'll do with certain clients is we can actually put those buffers on there for them in these DWGs. That way, we take the hassle out of your life. You can then see, okay, I know I can't put it there because of this water feature, or I know we can't put it here because there's an overhead electric line. All those things go into really making the perfect site, and at the back end, you get a full grading design so that you can accurately and at the least expense build that pad and reduce any kind of auditing in the future for any extended disturbance area or improper BMPs, all that kind of stuff.
Yeah, and so I know we've been talking about these 500-foot and possibly 1,000-foot. We're talking about a Colorado example. We're going to give, for any of the folks that are on the line from Texas, we're going to give a couple examples of where this really comes into play here in just a couple slides. But next, let's talk just quickly about another type of a deliverable that you're able to get. This is kind of in the same vein, I guess, as what we were just looking at. But Owen, maybe, I think you were actually on this location. Maybe you could talk to this example specifically.
Yeah, this is one, you can see we obviously were able to go out, fly this thing, collect new aerial imagery of the whole location being on the left, and off that, because we're conducting it as a survey in itself, we're able to put together that sort of full package exhibit, that front-end planning concept where we get all that topography. It was 1,000 acres that I flew in right about 3 hours worth of time on the ground / in the air. And with that, we were able to identify all key building features, waters, ditches, canals, everything that we needed and the client needed to help plan out that proposed location. And they actually had a few different alternates that they wanted, so we covered a really large swath. And from that, they were able to figure out where the best locations were for the least amount of cost that they can negotiate with the surface owner.
Wait, I know I'm getting a little older. Maybe my hearing's not as good. Did you say 1,000 acres in a few hours?
Yeah, no, it's a lot easier, it's a lot more efficient, it's a lot safer being able to do this from the air, because for us to be able to accomplish this same task on the ground conventionally, it would have been incredibly difficult, very time consuming, and we would have had to go and approach surface owners that they may not have had any idea that we were out there. And we're legally, per the FAA, allowed to overfly for gaining intelligence to help plan out proposed areas.
So that, you bring up a really great point right there. So are you saying that you don't need to get landowner permission to fly over their property?
Technically, no.
Okay.
There are certain restrictions that we do have to follow. We have to be careful about the way we plan out around roads and moving traffic. But in general, as a blanket statement, yeah, we can overfly parcels that we may not necessarily have permissions on, which again, from a standpoint of right-of-way corridors, flow line corridors, that you're trying to figure out where they can go and you may not have contiguous access, it's a really great option for that. And then one of the great things about this too that I think we're diving into in the next slide is actually you can see from a planning perspective this imagery overlaid in Google Earth, because ultimately what do most people use for planning to try and figure out where this is going to go on the front end? They stare at Google Earth and they try and figure out what makes sense. And the big question is, how old is that imagery? If you're down in Texas, let's say, there's a lot of work going on. There's a lot of pipe infrastructure going in. And even in Colorado, Wyoming, anywhere you go, lots of piping. And what we have an example here is from our UAV imagery, we could actually show what was on Google Earth currently, the same day that we flew it, compared to what we actually flew and collected. And you can see there's a new pipeline corridor going through there. If you didn't have that on your Google Earth view, you may have considered that you could actually plan something here, because this pipe may not be recorded yet in the state. So you might not be able to look up the actual easements that would be associated with it yet.
Yeah, and that obviously could be dangerous, it could be expensive, and it can be time consuming. Are these would this be an example, Nick, of what you were talking about earlier with one of those reasons why we'd have to go back out and resurvey a new location?
This is one of those things that really puts a hitch into the whole project, especially if you're dealing with a difficult landowner, or you only have a certain bit of a surface area to use, or even say you're in a high density population area. This could really ruin that project. And if you can look at that on the front end, imagine what you could do with it.
Okay, so let's just take a look at one other example. I think this might have been down in Texas, right?
Yeah, this was down in the Permian Basin where a lot of, due to I think caliche and some other factors, they do a lot of their flow lines from the wells above ground. So you can actually see kind of as the arrows are populating there, you can see the flow line that is certainly not shown on the current Google Earth imagery. You can see a scar that's been put in, so that's a whole new gathering line that's gone in that location. And in this specific example, our client wanted to put a new location right within this zone. And had they not had the imagery, because things weren't recorded yet in the state, they may have started planning ahead and then had to spin their wheels back, finding that out after the fact.
Yeah, yeah. This would obviously be a huge time saver to know all this on the front end, and then once you've gathered it, to all just sit in the comfort of your air-conditioned office and pull up your computers and say, okay, where do we want to put this thing, right? Yeah. Okay. So what are we looking at here then? Oh, and just as a disclaimer, this is a video, and we're going to attempt to play this. Hopefully it'll come through okay on the side of the viewer. It may be a little kind of jumpy just through the connection, but yeah, well, let's go ahead and talk through this. What are we looking at here?
Yeah, so out of the actual imagery that we collect, the surveyed imagery that we collect from the air, you get beyond just the orthomosaic, the updated aerial, your Google Earth view. You can actually create, because what it's ultimately doing is we're stitching together hundreds of thousands, millions of points to create an all-over colorized 3D surface. And so what you're looking at here isn't the actual path of the UAV flying around. This is actually what we did as an animation of the three-dimensional surface, buildings, features, everything that you could visibly see on the ground from the air. So as far as a direct visualization, if you're in a planning meeting with your team trying to figure out where's this location going to go, where should this flow line corridor go, we can produce these as an easy byproduct from the imagery and the work that we already do to help you guys plan out what exactly is in the area, where you want it to go, and what could be potential impacts, all in a real colorized 3D environment.
So just again, because I am the layman here, so I'll just break it down to layman's terms. So what we were looking at, again, this is not a video of a drone flying around a location. What we're actually looking at here is a data set, right? This is all underlying data that you could measure from and you could plan based off of with very good accuracy, because this is just a image laid on top of data.
Of the point cloud,
exactly. Of the point cloud. Okay.
Yeah. So that's what we generate all of the features, those examples that we showed you earlier with the contouring and the features being extracted. We're pulling that out of the point cloud that's underlying this colorized fly-through.
Wow. Wow. This is pretty cool stuff. So let's just kind of recap this section here and talk about the deliverables, because that's really ultimately what the clients on the line here wanting to hear about. So again, to reiterate, we're talking about standard deliverables. Are you still going to get those location plats, exhibits, topographic maps? The answer is yes, of course. Everything that you're used to getting today, you're still going to get. It's all those things below, the point cloud, feature modeling, orthomosaics, up-to-date aerial imagery and/or video, and fly-throughs and things like that. There are multiple different types of uses that you can use these different deliverables for, but it really is all going to be based on the project. We have a webinar that we'll be doing next month on midstream operations, where a lot of these things are very pertinent. Some of these same exact type of deliverables are great as you're going through and building and progress reporting and for construction purposes and things like that. So now let's go ahead and switch gears, and now let's talk more about UAVs and LiDAR. For the purposes of as-built, let's talk about facilities. And then I think another one that's important, especially to the folks listening in from Colorado, is talking a little bit about flow lines and how we would be able to kind of get as-built on some of those. So why don't we start here, and let's just talk a little bit about how does the process work today, and then what are some of the basic challenges and ultimately what some of the negative business outcomes are of those challenges.
Yeah, so when you look at different locations, and especially, like I said before, with the new regulations coming out, the thought starts to become, okay, we've permitted this and it works, but then what do you do with that data? How do you keep track of that asset? How do you know what's going on with that? The big thing is the facilities honestly are not mapped very well, especially in Colorado. We've heard from a lot of different operators that we kind of know where our lines are, or we kind of know what equipment's on there, but you can't really tell what that is. A lot of times we have clients call us up and they're getting audited by the COGCC. They built a disturbance area that may be a little bit too big. It's not permitted right. They have to go back through that permitting process. but the problem is they don't know what's actually out in the field, how it was actually built. So the main challenges we see there are you guys just don't have your data to go in and quickly respond to any governing agencies, to go in and look at retrofitting any kind of facility. Say a new regulation comes out for emissions. You know, you actually have to go out there physically to the field and look at it. The kind of stuff that we've been doing now actually allows us to 3D look at these kind of things in-house, make good decisions off of that, and actually plan these assets. So the biggest thing is if you have that data, go out there and get it, you know, and just move forward with it.
Yeah, because we kind of like the little farm-to-table concept where we're already out there. If we're helping you permit and plan the location and get the location planned on the front end, we take it through to the point with some of our operators that we work with that we stake out the facility. We help with the design process on the facility and the piping. Where does it all go? So while we're on the ground already staking out the facility, if there's infrastructure going in while we're there, let's collect that. That becomes a part of the as-built asset. Eventually, we can house and manage full life cycle models and facility information that you can use to move forward with. And that's a big portion that's missing right now is everyone, or most people have plans of what they want, but most operators and most facility builds don't actually have the as-built. And usually that'll be something that they'll order at a later time if they want to retrofit or add in. And we're trying to jump the gun by being able to take care of that at the front end. The second it's done, since we're already out there staking these sites, we're able to collect that, and then that becomes the facility model that you can move forward with.
And as many people are probably aware, I mean, we've seen a lot of stuff going into having 3D models of the facility piping and where that equipment sits, and the operators use that to build their facilities. Well, the truth is in that when they actually build these facilities, you run into issues. You run into problems where you have to reroute a flow line, or some piece of piping just needs to bend a little bit this way instead. So then when you go to actually dig that at a later time, you don't have that data, you don't know where it is. And if you are in Colorado, and even if you're in the oil and gas industry, I'm sure most of you are aware that Colorado put out the notice to operators that all flow lines will need to be mapped going forward and provided you know, the exact locations for those, and if they're abandoned or not, and live, and what do they house, and all those items.
And so just real quickly, and maybe 20 seconds on, you're our local surveyor here. If you were to go out and survey a facility conventionally, just for the people on the call that are not familiar with that, what would you have to do? You'd have to go and just shoot in each corner of the pipe? Is that how you do that?
Yeah, if I was a surveyor with the GPS, I would hit the key kind of angle points or PIs along the pipe. I would shoot the corners of the equipment, kind of make enough to make a general arrangement style outline. What we can then do instead, kind of to where you were going there, is if we were to scan out a location, so same amount of time on the ground, in fact, scanning takes less, we would actually get literally down to the nuts and bolts of that same exact facility that in what I would deem as less time. You get an immense amount more detail, and kind of your slide here kind of shows what I'm trying to say here is that you get 10 times, 100 times more than you ever would because you're just trying to create the basic outline. And in order to collect that basic outline, it takes a lot of time, a lot of energy, and we can actually turn it into the ISOPAC drawings, 3D models, everything we get out of scan data, where with the conventional survey, it's going to be more of a two-dimensional collection where we hit those key points, and it's enough to understand what's there, but as far as retrofitting and really adding on, you're not going to know and have that detail to really expand out and really have a controlled feel of what assets you actually have.
And so is it a fair statement to basically say that what we're, if I just kind of take it up a notch, what we're talking about is going out and collecting all this data the first time. So for the next 10 years that you're running that facility, when you want to go back and do anything, whether it's retrofitting, expanding, anything like that, or you just want to know where your flow lines or things like that are, we've already collected it one time, and now anything you want to do going forward, you've already got that data.
Yep, that's exactly it.
Okay.
That becomes your base of all operations out there.
And then we're also talking about really moving from not just a 2D world, but into a 3D world here too, right? Because this example on the right is a facility that you worked on, I believe, and being able to get this 3D type of a view is pretty powerful for clients too.
Yeah, because ultimately, if you're a facilities designer, you're the construction crew, you're a piping designer, you're going to be utilizing our 3D product, our model-based product that's on the right, to really design out and understand what you have in a 3D environment. While if you're maybe more of a construction foreman, you want to know specifically how many tanks do I have, what size diameter are they, we can still produce the standard two-dimensional kind of deliverable, the general arrangement on the left that a lot of people are used to getting. And that's the great thing about collecting it this way, is we can create basic outputs out of it, or we can do really advanced versions where you can even animate it, like we'll probably show you here later on, and have a better understanding.
Great. Well, why don't we talk about, just quickly, kind of up-to-date aerial imagery as it relates to as-built?
Yeah, so one of the nice things is that if we have the survey permissions to already be on site, we can legally, and again, not, in most places, be able to send up our UAV, one of our visual drones, and we can collect photos, video. We can use that for scouting, scoping, and for all over progress to see where are we sitting. Are we sitting within right of way? How's, where is everyone putting equipment? Where's everything being housed? You can get status updates of rig sites, corridors, a variety of different pieces of information, all just from the air, from some photos and video, since we're already out there.
Yeah. Yeah, that makes sense. And getting that bird's eye view is very different than just looking at emails and people describing what's happening. I mean, you can capture so much more just with a visual aid there than just reading through a bunch of things. So what about the earthwork and kind of the pad build itself?
Yeah, so the big thing comes down to that disturbance area. As everyone knows, a field is not actually flat. Just making sure that you have the accurate data and really planning out that site to make that build work is what the ultimate goal here is. And then on the as-built side, what does that pad actually look like once you complete it? We've had a couple clients where we've actually gone out and, multiple stages. So there's the preliminary stage where we collect the flat ground. The next stage where we go out, they've gone in, they've done the dirt work, we get that data, what's the actual disturbance area now? Send that off. You can actually plan out then exactly where all of your equipment's going, exactly how that's going to look, and create all those points for staking. Just make sure that facility is going to work for you. So, the big thing is that if you can take those at different stages and know exactly what it is at the end product, you can always move forward with that data.
And since we've already been out there, it's a really quick flight with the UAV. We're able to go out and collect that in a very short period of time, and we get really nice values on a graded surface like that, and we can give you new elevations to adjust your models and make sure you build it exactly as you want it.
Yeah, and so this is probably a good segue then into this next one. Again, we're going to show another fly-through here. We showed one of these earlier. Just again, a quick disclaimer, this may come through a little choppy on your side as the viewer over there, but that's just due to some of the connection. If you see this, if we come out and get a chance to chat with you, it's actually much smoother. All right, so Owen, you just kind of want to talk through this?
Yeah, so this was we'll have two examples here. This is a UAV. Again, this is one of those animated fly-throughs of the colorized point cloud that we were able to collect. It was a active rig site that was right next to a facility that was being built. We get the full picture of where does it sit. We can underlay the outlines of the actual line work for the disturbance, the pad locations, all the legal information. But in the end, it gives this bird's eye view in this nice, clean animation of what's out there. You get a really good feel. If you're someone that hasn't been on the ground to see this location, you can see it based off a quick flight in the air. And then if you want to advance forward, so
sure.
This next one, I believe, let's see if this plays. Next one, it's a little choppy, a little difficult to see, but this is that same facility actually scanned on the ground with our terrestrial LiDAR. The white and blue pieces that you're seeing are facility equipment and piping that we modeled through to understand the separation vessels, to have data for those that we could extract and give to the facility design group, so that way they can start their asset tracking. Because again, the big key with all this is you can have a plan, design, and have an intention of where it needs to be, but actually understanding exactly where it is. We can go scan on the ground in a period of a few hours, do the flight over that you saw in that previous slide, and then collect the millimeter accuracy point cloud with the LiDAR that we can really use to model and create those pipe layouts with.
Yeah, and so let's try and take an example of actually doing that modeling here, and we'll get this to play here in just a second. What does that really take? I mean, once we've gone and collected that data, what does it take to actually go through and model like what we're going to see here in a moment?
Yeah, we like to be able to use common types. We work with our clients to figure out what programs are they using, what can they use to consume this on the back end. And we always do software specific needs. And ultimately we're able to, kind of like you have it freeze frame there, we're able to take that pipe down to a certain inch, and we can create a library of features that we can start to plug and play in different models. So if you're an operator that uses a lot of the same equipment on all of your sites, we can create those copies and start plugging it in based on that point cloud that we showed you. And ultimately, this is what your construction and facilities design team would need to really understand what the facility looks like and what you can do to make it work.
And so when we're just high level here, when we're talking about accuracy, what type of accuracy are we talking about?
It's dead on. I mean, it's literally centimeter accuracy.
Okay. And so, so we've looked at some of those different types of deliverables. You know, one of the things that we use with clients that they absolutely love is a online 3D viewer. So maybe you could kind of talk about how we use this and how our clients are using this.
Yeah, and so the last piece that you just saw there, that's what, the really technical folks would use and consume. That's what they would use to look at the facility. But if you're someone that maybe doesn't have Navisworks or one of these technical programs, you can hop on through an online access viewer that anyone that we give credentials to can view, and you actually get into these views that we call True View, that you can become the head of our LiDAR scanner. You can look around within the point cloud. You can pull measurements of different piping. It's a really great tool that anyone can use, and it gives you that kind of Google Street View perspective from each location that we set up at to really understand what the facility looks like today without ever having to go on site.
Yeah, and we can't show it here today just for the sake of time, but this is a really neat tool, and if you'd like to learn more information about this, obviously contact us. We'd be happy to come out and show you what this online 3D viewer can really do, because it really gives you that. This is just a normal point cloud with some modeling going on. When a colorized point cloud happens, it's as if you're standing right within that area, and it's basically like you can be standing and going all the way around getting a tour of that facility without actually having to step outside your office. So yeah, retrofitting layouts, this is pretty simple, but this is just an example of just another type of deliverable, right, Owen?
Yeah, we've started to take basic engineering exhibits, architectural elevation plans, that you can take it just from someone going out with a tape measure, and the same amount of time it takes to run around and collect all these physical measurements and get right up next to these fired vessels. You can do it all from the outside, same amount of time, and produce this type of exhibit on the back end for permitting, for retrofitting and layouts to make sure that you're meeting those legal locations.
Great. And so when we're talking about asset management, I know we brought this up earlier. Nick, you just want to kind of talk about this real quick?
Yeah, so the main thing is just keeping track of the data that you have. There's a lot of different systems out there to do it. This is the system that we provide. It basically gives you, it's an online GIS tool. We go in, it's called PAM. We pull all the data from all kinds of different sources to give you any kind of county, parcel lines, all the hydrology, that kind of stuff. And then we actually load in through our SDE database all of the survey data that we collect. We show where these locations are. We show where your surface, landing point, and bottom hole locations are. and really allow you to plan it. So you've got all the section line work in there. You know, it's mainly a planning tool that houses all of the data so that, you know, if I'm talking to a client, we can have a full conversation over the phone and we're looking at the exact same thing. Really great tool, and the good thing about the SCE database that everything connects into is we can pull any of that data for our clients at any time, well locations, anything like that, and you get the full data. So really nice tool. And then with the CAD, you know, we're a survey and engineering company, so any kind of different need that you have, we can make it happen with the software available. So.
Yeah, and when we're talking about asset management here, we're essentially just talking about one central location. I know some of our clients have, obviously, a lot of them have a GIS type of database, but you know what we often hear is that there's not one single location where all of the different type of as-built data, as an example, resides. And Owen, correct me if I'm wrong, but you can actually load some of those other deliverables we talk about, or have at least links out to the 3D online viewer. So if I was to go to my asset, see my facility, I could click on a link, and it now takes me, you know, virtually inside of that facility, right?
Yeah, absolutely. We can load up the 3D viewers. We can put in the aerial images, any content that you would want in there. We can custom build these out. And we have really great success with this as a tracking product. Our customers can see where we're at in the process. They can see all the deliverables, the byproducts. There's a lot of great things coming out of the Asset Manager.
Great. So like we mentioned before, you know, when we talk about deliverables, obviously standard deliverables, absolutely. And then there's all these other types of deliverables that we can provide when it comes to facilities in some of these areas. Getting that as-built data and getting it into a 3D type of a model is extremely helpful for all the future projects that you would want to work on with that particular area. So let's just do a quick recap here. I'll just kind of run through these pretty quickly for the sake of time. You know, what we're really talking about is a blended approach here. So we're not saying go away from conventional surveying. This is a blended approach where it's partly conventional. I mean, there's certain things UAVs and LiDAR aren't going to be able to do. Owen, correct me if I'm wrong. I don't think that the construction staking UAV has come out yet, right?
No, there's not a UAV that can shoot a stake into the ground yet. There's not a UAV that can uncover a monument 3 feet below the ground yet to define the boundaries. So
thankful for that. That might be a scary day. But what it can help with is the planning and the location, where we're going to put this thing. And then, you know, when you start looking at analyzing all this data and ultimately giving you different types of deliverables to work off of, you know, we're talking about a blended approach here. And really, if I was to summarize what we've been talking about today, it's these 4 categories. One is it's safer. I mean, when you're flying above and you're not walking through rattlesnake-infested fields to collect some of this data, that's going to be safer. When you're not standing in the middle of a trench, that's going to be safer. We're talking about collecting more data on the front end. When we talk about less time, there's a lot of areas we could dig into there, but instead of going back out to a single location 4, 5, 6 different times, we're talking about just going out there once, collecting more data, and then being able to just work off of that data set going forward. And ultimately better deliverables. So what we're talking about here is getting away from just the standard 2D into more of a 3D type of a world, and being able to have more types of ways of looking at this to make better business decisions ultimately. A couple of recommendations we would have. Firm with oil and gas experience. If you're going to go out there and look at this, we would recommend you're working with a company that has been working in the oil and gas space, so they understand the terminology, understand you know, these types of locations. Number 2 is a survey firm first. There's a lot of drone companies coming out nowadays that can go out and fly a drone and take some pretty pictures. It's important to work with a company that it really comes from that survey firm first background, because then they understand the geospatial nature of the data that they're collecting. A full service firm is extremely important. When I say this, I'm talking about a company that not only collects the data, but processes it, analyzes it, manages it, and then ultimately gives you a deliverable that you can use to make business decisions. And we see this all the time. I put this in here by being very particular, because this is an issue we see all the time with companies calling us up saying a company went and collected data and then they just handed it over to us. And then they ask us if we can actually do the analysis and give them the deliverable they were hoping for. You don't want to do that. You don't want to parse that out. You want to work with one firm that can do the entire thing for you. And then a firm that understands from a consultative approach what you're trying to do, obviously does it safe, and then maybe ultimately can help you from an asset management standpoint to make sure that all the data they're collecting can then be managed properly going forward. So with that, that kind of concludes the presentation itself, but I'd like to go into any types of questions that have come in throughout this. So let's go ahead and take a look at any questions that you may have had that have come in. And it looks like we've got a few that have come in. So let's go ahead and take this first one. All right, here's a question. How much does it cost? And what are the cost savings? Well, I am not surprised that we got that question. That's obviously a common one. I'm not sure how to really address that in a minute or less, but let me do a good job, or try and do a good job of stating that. How much does it cost? That's dependent on every project, right? Every project is a little different. So I hate to say it depends, but unfortunately that's kind of the answer. And then what are the cost savings? I mean, I think we can all agree, if you're not sending a survey firm back out to get and collect data again and again and again and again, then you're going to have savings because you're not paying them to go back out there. You've also got the time savings of, you know, other factors we talked about where saving time, that can be money, and also, you know, safety factors and being able to have all that data and everybody working off of the same data set. There's a lot of indirect costs that go into that, cost savings that go into this as well. Anything else you guys would add there?
No, I think the all-over life cycle, like you're saying, you're going to have a combined savings across the life of these projects that you can't realize directly right at the front end.
Yeah, that's a great point. So, you know, what we tell clients a lot of times that ask us, you know, how much does this cost? We always tell them it's not going to cost you any more than what you're doing today. The difference being is that you're going to get more data, and it's going to take less field time on the front end, and ultimately you're going to have better deliverables, but it's not going to cost you any more. But when you look at the overall life cycle, the entire project, absolutely, you know, there's cost savings. We just don't have that empirical data because every project's a little different. Okay, so our next question here. Do you still provide basic exhibit packages? I know we kind of talked to this, but maybe Nick or Owen, one of you guys can address that.
Yeah, for sure. That's the whole thing here is we still do all of the regular plat packages. Everything from the well certs to your multi-well plans to your other permitting exhibits that are specific to that location. We still provide all of those. The big thing to all of this is if you have another issue, if you have any kind of problem, any kind of question, we can address that immediately because we have the data. You know, any kind of other custom exhibits that you or your company may need, say that you're working on a use by special review type of project and you have to go to these hearings and these town hall meetings. What better way to show what's going on and where this is going to be and how it's going to impact that community than having this data available, having that video of the fly-through, you know, up-to-date aerial imagery, then everyone can see what's going on and you can show that you're being transparent, you're doing everything legal, you care about the community, and you want to develop these minerals in a responsible manner. So that's exactly it. You'll still get all the regular plat packages, and if that's all you want, that's fine. But there's so many more uses for this data that we can definitely come up with all kinds of innovative solutions in that manner. So.
Excellent. Well, we probably only have time for one other very quick question here. Let me see. How do we work with this type of data not used to dealing with LiDAR data? So I think if I'm understanding that question correctly, basically what the person is asking is, you know, what happens if you just hand deliver a huge data set to us? What are we supposed to do with that? So Owen, why don't you take this one?
Yeah, I mean, generally we're not going to hand you off a giant point cloud with millions and millions of points. It doesn't do you a lot of good because there's a lot of work you have to do to make it usable. Or not a lot of work, but it just takes the right tools to make it work. So we're ultimately, if it's planning, we're going to develop that surface model. We're going to extract the line work and features and everything that's relevant. and toss it into a small, well-kept DWG file, a CAD file, a shape file, and send that off. So that way your planning team, your GIS team has all that easily available to go.
Okay. Okay, that's great. And I'll just add on there, so, you know, again, we start with the deliverables first. We don't actually start with, you know, trying to understand, you know, how we're going to go collect it. And then we start with the deliverable you're looking for first, and we want to understand why you need the deliverable. And then we'll work backwards from there on what we need to produce in order to get you that deliverable, and then how we need to collect it ultimately is the last step in that. Okay, maybe we got one other question that kind of came in here too. Looks like you had underground piping on as-built models. How do you obtain the accurate underground info for as-builts?
Yeah, I mean, that's, you know, there's a number of different ways of going about that, and that is very project-specific based. We try and combine it together if at all possible, when possible. So if we're out staking a location and there's piping being shown and visible, we collect it then. If we're going for over-excavation, we're laying out full piping structures before we backfill in, we'll get out there at key milestones and we'll scan in those piping locations. So that way you know exactly where those are sitting. So that way when we create the above ground model, they'll place right on top of that. It's very project specific, would you say, Nick?
Yeah, it's project specific, and I mean there's other bits. If your company is obtaining 3D models, you know, from an engineering group for these facilities on the front end, and you have that original thought of that model, you know, like I was saying before, there may be some differences in the way it actually gets built. It won't be too much different, obviously, because there's a lot of thought that went into that. But you know, if you're happy with it and it gives you enough confidence, we can even take that produced 3D model and go out, scan the above ground facility once it's done, and then marry everything together and connect up. So that's another option of how to do that. Otherwise, I mean, the best course of action is definitely, while the trenches are still open, to either conventionally or scan or fly the drone. You know, whatever instance makes the most sense, is the most efficient and cost efficient for our clients.
Yeah, it's all about making it fast and easy and staying out of the trenches too. So everything we do, we collect it remotely, we collect it quickly, so that way crews aren't waiting for us to backfill.
Exactly. Well, for the sake of time, unfortunately, we're going to have to cut this short. We'll try to address some of these questions to you directly if we do have your name. Otherwise, if you have any questions about anything we covered today, or if you're just interested in learning more about it and chatting with us about some potential projects, my information is down there on the bottom left. Keith Hewlin, khewlin@ascentgeomatics.com is how you can reach me. You can also reach me through our website. We appreciate everybody joining today, and we will have one more of these in about a month, focused more on midstream operations. So thanks again for joining us. Nick, thanks for the expertise. Owen, thank you for the expertise. And you guys have a good rest of your week. Thank you.